Hi, welcome to AVM Math Hub. Today we are going to discussing about CSIR net linear algebra problem on December 2019. Problem: let T maps C power n to C power n be a linear transformation n greater than or equals to 2. Suppose 1 is the only eigenvalue of T. Which of the following statements are true? Option 1: T power k is not equals to I for any k belongs to n, where k is any natural number. Second option, T minus I whole power n minus 1 equals to 0. And the third option, T minus I whole power n is equal to 0. The fourth option, T minus I whole power n plus 1 is equal to 0. So by using these four options, we have to find a T is a linear transformation. So which option is the correct option for the given statement? Here T is the linear transformation from Cn to Cn, and 1 is the only eigenvalue of T. That means all the eigenvalues of T are 1. Now we check all the options one by one. Answer option 1. We check option 1. Option means option 1, T power k is not equals to I for any k belongs to n. If T is equal to I, if T is equal to an identity, then all the eigenvalues of identity matrix is 1. Then 1 is the, then in the given condition, 1 is the only eigenvalue of T. So 1 is the only eigenvalue of T. So if T is equal to I, where I is an identity matrix, we know that all the eigenvalues of identity matrix is 1. If we take T power k equals to I for all k belongs to n. For all k belongs to n. Since it satisfies the condition 1 is the eigenvalue of T. So for all k belongs to n. So n is the natural number. So k is equal to 1, T is equal to I. So here T power k is not equals to I. So the option 1 is wrong. Check option 2. T minus I whole power n minus 1 is equal to 0. In option 2, if we take T is equal to 1, 1, 0, 1. So here 1, 1 is the eigenvalues. 1, 1 is the eigenvalues. Because in the given condition, 1 is the eigenvalue of T. That's why we can take this matrix T is equal to 1, 1, 0, 1. So since 1 is the eigenvalue of T, so therefore T minus I whole power n minus 1. Suppose for n greater than or equals to 2, suppose we can take n is equal to 2, 2 minus 1, 1. That is equal to T minus I. So T minus I whole power n minus 1 is nothing but T minus I. That is equal to T minus I means we subtract. So then subtract 1 from the diagonal matrix. 1 from the diagonal matrix, this will get to 0, 1, 0, 0. So this is not equals to 0. So option 2 is wrong because this is 0. T minus I, here T minus I whole power of n minus 1 is not equal to 0, non-zero matrix, but in the option equal to 0. So option 2 is also wrong. Now option 3. T minus I whole power n is equal to 0. T minus I whole power n is equal to 0. Since 1 is the eigenvalue of T, Since 1 is the eigenvalue of t, then all the eigenvalues of t minus I are zeros. Therefore, all the eigenvalues of t minus I are zeros. Why? Because 1 is the eigenvalue of t. So 1 minus 1 is equal to 0. So here I can write, because 1 is the eigenvalue of t. So 1 minus 1 is equal to 0. In the diagonal elements 1, 1. So 1 minus 1 is equal to 0, and 1 minus 1 is also 0. So all the eigenvalues of t minus I are also zeros. And that implies t minus I is nilpotent matrix. Nilpotent matrix. Nilpotent matrix. By the definition of the nilpotent, t minus I whole power n is equal to 0. So if t minus I whole power of n is equal to 0, then t minus I whole power n plus 1 is also 0. In the option t minus I whole power of n is equal to 0, t minus I whole power of n plus 1 is also 0. So option 3 and 4 is the right answers. Therefore, option 3 and option 4 are right answers. Hence solved. So this is the procedure. We have to solve any problem by using the conditions. Thank you so much. Have a nice day.